Hi everyone, today I'll be doing a question from the 5th SAT practice exam that College Board released on Blue Book. And if you happen to be taking the exam either in August or during the fall, then I suggest giving this practice exam a go before we work through this together. Now, I happen to be preparing for the August SAT exactly a year ago. As you can see, the date here is August 10th, 2024. And while I was focusing more on the reading and writing sections of the test, I wanted to make sure that my math abilities were polished enough so that I could be able to do the questions to the best of my ability. All right, without further ado, let's dive in. The first step to any problem is reading the problem carefully and making sure we make the most out of the information that it gives us. And so let's read it together. The graph of the linear function y equals f of x plus 19 is shown. If c and d are positive constants, so positive constants is probably going to be an important condition here, which equation could define f? And so as I'm reading this problem, I always try to scan for keywords or phrases that could hint at some important aspects of a problem that we should pay attention to. And so here, C and D are positive constants, and so we should note that in the corner of our mind while we're solving this problem. I also noticed that the graph is shown to be a line, but most importantly, the question tells us that the function not only looks like a line, but it is a line, because a linear function is exactly describes a line. And what we're trying to find is what form f could be. All of the answer options give us potentially valid solutions for f. Now, when I see an SAT math problem, I often think of a couple different approaches that I could go down through. And if one doesn't work, I could always try another one. So one maybe more straightforward approach is maybe finding exactly what y is, because we're given the graph of y, and from this graph we could deduce the value of y. And we got to be a little bit careful here, because y and f of x are not the same thing, because y is defined as the function f of x shifted up by 19, or mathematically speaking, it's just f of x plus 19. So there's just not the same thing. So I'm going to write that down. Our first approach could be finding y. Finding an expression for y. So I'll just write an expr for y. And why could that be useful? Well, if we subtract 19 from both sides, we get that y minus 19 equals f of x. And so once we have an equation for y, we can substitute that back in to our manipulated equation to form f, and then we'll eventually see if that helps us at all. A second approach I'm thinking about is considering the different forms of the answer choices. And so usually in a math problem, especially on the SAT, I don't usually think about answer choices, but if the problem gives you some constants or variables that aren't very well defined, like positive constants could mean anything from pi to 3 to 2.1, then I could think about what it really means to have f as maybe one of the answer choices. And maybe we can find a way such that we find the correct form of f. So I'm just going to write finding the form, or Actually, I'm going to just write finding possible form for f. Okay, so let's try approach number one, which is arguably the easier way. So let's find an expression for y, which is the equation for the graph of the line that you see in the diagram. So because we know that y is linear, we can express y as mx plus b, where m is the slope and b is the y-intercept. What's interesting here is that you could find the equation of a line using point slope form, but for me, my personal preference is just the slope intercept form, because here we can easily find the intercept, which is 3. So I'm just going to write b equals 3. And then we could also find a slope. And remembering that slope is rise over run, we have rise as 1, 2, 3, 4. If you're not sure that the point over here has both coordinates as integers, you could also consider this point over here. And so as I was reasoning before, this is a rise of -4, and here a run of 1. So our slope is rise over run, which is -4 over 1, and that's just -4. So therefore, our equation is y equals -4x plus 3. And you could have also done it with another way, like point slope. So now that we have an expression for y, we can solve very, very easily for f. And this means that we can plug this expression, this formed expression for y, all the way back here. So substituting that back, we get y. Well, we can just substitute the whole expression. We're going to do -4x plus 3 minus 19 equals f of x. And now we get f of x equals -4x minus 16. So now we have an equation for f, but we don't have an answer choice that says -4x minus 16. So if we remember what we stored in the corner of our mind, alternatively, we could reread the problem, which is definitely a wonderful idea at any point of the problem. C and D are positive constants. So let's see which of the answer options matches this form that we have for f. So if we have A, f of x equals -d minus cx. And so we can see that it pretty much matches because, again, c and d are positive constants. So here we can see that c equals 4 and, oh, my bad. C equals 6, or c equals 4 and d equals 16. So we can confidently say that A is the correct answer. Now we could obviously check B, C, D, but note that in B and in D, the intercept is positive. And so from our form of f, we know that the intercept is -16, which is not positive. So that rules out B and D. And for C, we know that from our function f, the slope is -4. But in our answer choice, the slope is positive c, and that's a positive constant because c is a positive constant. So c can't be right. So the answer is A. Now let's tackle this problem using the second approach that I proposed. Now, while this may seem a little bit abstract, we're going to focus more on the properties of f. And we can see that because only one of the answer choices is right, we can see that only one possible form of f can match such that y is the graph of this above expression. Okay, so rather than working through each of these answer options, which could work, let's instead say that f of x equals a plus bx, where we don't know the signs of a and b. Let's just temporarily remove this constraint that c and d are positive constants and make them into a and b. Because note that here that in the answer choices, they give all possible combinations. See, in A, you got two negatives, and here we're assuming that C and D are positive constants, but like afterwards we're not assuming so. But temporarily assume that C and D are positive constants here. A has two negatives, B has one positive, one negative, C has one negative, one positive, and then D has one positive, one positive. So it has all the combinations. Just to make it clear, I'm just going to write it as two negatives. So instead of thinking about like C and D as positive constants and then maybe getting a little bit confused about the signs along the way, let's just assume temporarily that f of x is a plus bx for any constants a and b. And this helps us as to find a form of y that matches this expression over here. Okay? So assuming this form, right, ax, a plus bx, we can say that y is just 19 more than f of x. And so y equals f of x plus 19 becomes y equals a plus bx plus 19. And we can just group these together into a plus 19 plus bx. And reason for grouping that is to see eventually that this will help us deduce the signs of a and b. Okay, now let's look at our graph and let's deduce whether a and b are positive or negative. So the form here, I'm going to write it again, is a plus 19 plus bx. And because the slope is negative, right? This line is just a downward line. We can see that b is less than 0 without even calculating what b is. So that immediately means that this slope, or rather the coefficient of x must be negative. So that means that C and D are out. So we can immediately rule out C and D. Okay, so now what about A, right? Because A plus 19 is kind of an abstract quantity. Well, we can deduce that the intercept is very easy to see. The intercept is just around here, and that's just 3. So the intercept, again, just recalling very quickly that the slope-intercept form, y equals mx plus b, the b, where the b represents the intercept. Same thing for a plus 19, and a plus 19 is just the intercept here. So now we can say that a plus 19 equals 3, just matching the coefficients. So we can say that a plus 19 equals 3 and a equals negative 16. So therefore we know that a is negative. So we now know that because a is negative, we can rule out b, and that gives us a. So remember that we were like assuming that a and b don't necessarily have to be positive constants. And why do we really like assume so? Because that seemed to be like breaking the rules, right? C and D have to be positive constants. Well, that's a very useful problem solving strategy in some cases where some conditions may be useful in solving the problem, but you want to assume, but you are able to temporarily bend the rules at your whim so that the problem could be solved much easier. Like here, we didn't even have to. Here, when we solved the problem, like we didn't really assume whether A or B are positive or not. We just found it from the graph and our assumed form here. And this way, in a sense, is also a little bit easier because you get to directly find the sign of the slope and the y-intercept of f without much computation. The only real computation here is just this step. Is just a plus 19 equals 3, just like matching the coefficients, or rather matching the intercepts, and as well as this, where you substitute a plus bx in for f and rearrange a little bit. But these kinds of simple tricks can save you a lot of time for SAT, for the SAT math, especially if you're flexible enough, then you're able to solve many more problems, and especially the more difficult ones, where there may not be such a slight approach, and you got to be flexible with the skills that you have already acquired through math class. I hope you learned something new from this video, and see you in the next one.